Thank you very much. Ladies and gentlemen, my students, good afternoon. I'm teacher Babu Owino. Today we are ready to take you through mathematics, and the topic is on matrices. Before we start our topic, we know what we are going through. There's a serious pandemic that is causing a lot of pandemonium in the global village, and that is coronavirus. So I would like to tell you that you adhere, you follow and strictly follow the rules and regulations which are set to help us curb the spread of coronavirus 2019. Ladies and gentlemen, make sure you put on your masks, you wash your hands, you sanitize, you keep social distancing. Things are not safe yet. We are not safe yet. My message number 2 goes to my Muslim brothers and sisters. Assalamu alaikum. I would like to dedicate this class today to my students, my brothers and sisters from the Muslim community, and all the candidates across the nation. We are aware that we are in our last 10 days of Ramadan. Therefore, we ensure that tutafute to ensure that tuhakikishe tutafute Leila Turkad. Asanteni sana. I hope you will enjoy the lesson. So today we will start with matrices as our main topic. So on matrices we will look at introduction, then after the introduction we will go to the order of matrices, order of a matrix. Then the third one will go to addition and subtraction of matrices. Number 4 will go to multiplication of matrices. Then we'll go to types. The type of matrices, we have 0, 0 matrix, we have singular matrix, the third one we have identity matrix, we have determination of a determinant, or rather the inverse of a matrix. So then the last one will deal with the application. Where is it applicable? Application of matrices. So by the end of the lesson, what we want to achieve is to know what matrices are, the order of a matrix, addition and subtraction, multiplication of matrices, types of matrices, and then the application of matrices. So when we start with the introduction, so what are matrices, or what is a matrix? So matrix is the arrangement of numbers or arrangement of items in rows and columns. Arrangement of numbers or arrangement of items in rows and columns. For example, if we have a farmer or if you have farmers, and these farmers, they keep chicken, cuckoos, they keep cuckoo, or they keep cows and goats. Then we have farmer A, farmer B, and a farmer C. So farmer A has 1 cuckoo, has 2 cows, and has 4 goats. While a farmer B has 6 cuckoo, then cows, he has none, 0 cows, then has 2. Then another farmer C has 2 cuckoo, then cows, let's say he has 1 cow, and goats, he has 3 goats. The way they are arranged, this is the arrangement of numbers. This is called a matrix. Matrix. Suppose, again, we have another example. Example 2. This is example 1. Suppose we have another example where we have again the farmers. And then again we have the cuckoo, the cows, and the goats. So here we can have farmer D, farmer E, and farmer F. So farmer D has like 2 cuckoo, 4 cows, 6 goats. Farmer E has one cuckoo, 2 cows, 10 goats. Farmer F has 0 cuckoo, cows 0, and goats 2. This is also called a matrix. This is also called a matrix. So we have this matrix and we have this matrix. When you combine the two, we get matrices. Matrices. So when we get this and this, their combination is matrices, the plural. This is a matrix, this is a matrix. The two of them makes matrices. We want to go to naming of a matrix, or the order of a matrix. And in determination of the order of a matrix, number 1, suppose you are given 2, 1, 5, 6, 3, 2, 1, 4, 8, 5, 2, 3, 4, 5, and again another example, 2, 1, 0, 4, 8, 9, 1, 2, 1. How do we name these matrices? In naming of a matrix, or in getting the order of a matrix, number 1, you start by counting the number of rows that matrix has. Then you go to the number of columns. So like in our first one, we have rows. Rows run horizontally, while columns run vertically. So if our first matrix is 2, 1, second is 5, 6, 3, 2, 4, 8, 5, another one is 2, 3, 4, 5, next one is 2, 5, 3, 6, 4, 7, the next one is 2, 4, 1, 1, 8, 2, 0, 9, 1. Suppose we have such matrices. How do we name them? I said that number 1, you name them as per the rows and columns. So in our first one, we have 1 row and then by 2 columns. So this is named as 1 by 2 matrix. How do we name this? 1, 2 rows by 1 column. So this is a 2 by 1 matrix. So the next one is 1, 2, 3 by 1 column. This is a 3 by 1 matrix. If we go to the next one, we have only 1 row by how many columns? 1, 2, 3 columns. This is a 1 by 3 column. When you come here, we have how many rows? 1, 2 rows by how many columns? 1, 2 columns. So this is a 2 by 2 matrix. When you come the next one, we have 1, 2 rows by 1, 2, 3 columns. So it is a 2 by 3 matrix. The next one is 1, 2, 3, 3 rows by how many columns? 1, 2, 3 columns. This is a 3 by 3 matrix. So in naming a matrix, you simply name the rows and the columns. Rows run horizontally while columns run vertically. So that is what we call the order of a matrix. It's as easy as that. And believe you me, students, matrices just needs concentration because it's very easy. There is no confusion about it. It's an easy topic that you can score everything when it comes to examination. So we go to addition and subtraction of matrices. So from here I want you to be a little bit keen. So here, if we have a matrix like 1, 2, 3, 4, let's say this is A equal to 1, 2, 3, 4, B equal to 5, 6, 7, 8. The only way you can add or subtract matrices is when they are in the same order. The same order means this is a 2, 1, 2 by 2 matrix, and this is also a 2 by 2 matrix. Because they are in the same order, you can add them or you can subtract them. So let's say we want to get the value of A plus B. How do we get A plus B? Just write the matrix A, which is 1, 2, 3, 4, then add to matrix B, which is 5, 6, 7, 8. So when you are adding matrices, these are called elements. These numbers in a matrix is called elements. This is element 1, element 2, element 1, element 2, element 3, element 4. So the first element, you add it to the first element on the other matrix. So this is going to be, the first element here is 1, add it to the first element here is 5. Then the second element here is 3, add it to the second element here is 7. Then the third element here is 2, add it to the third element here, which is 6. The fourth element here is 4, add it to the fourth element here, which is 8. So what do we get? This is going to be 6, 10, 10, 12. So A plus B equals to 6, 10, 10, 12. Now from here, we want to get B plus A. That is A plus B. What if we get B plus A? So B plus A, you start with B. Our B is 5, 5, 7, 6, 8. Then you add it to 1, 2, 3, 4. So I told you when you are adding the first element on this matrix A, B, you add it to the first element on matrix A. So here is 5 plus 1, you get 6. Then 7 plus 3, you get 10. Then 6 plus 2, you get 8. And finally 8 plus 4, you get 12. So class, I want you to note something here. A plus B is 6, 10, 10, 12. B plus A is 6, 10. This plus this 8. When you come here, now the first element here is 1 plus 5, which is 6. Then 2 plus 6, not 2 plus 8, sorry, 2 plus 6. 2 plus 6. So this is 8. Sorry, class. So when you look at this, it's the first element plus the first element, which is 6. 1 plus 5 is 6. 2 plus 6 is 8. 3 plus 7 is 10. 4 plus 8 is 12. When you come to the next, the first element you add with the first element, which is 5 plus 1 is 6. 6 plus 2 is 8. 7 plus 3 is 10. And 8 plus 4 is 12. So class, we have A plus B is 6, 10, 8, 12. B plus A is 6, 10, 8, 12. Therefore, we can conclude by saying that A plus B equals to B plus A. Just mark this, put it at the back of your mind. Then, the next one, we want to subtract the matrices at the same time. So from here we have A is 1, 2, 3, 4. Our A is 1, 2, 3, 4. And our B is 5, 6, 7, 8. 5, 6, 7, 8. So in subtracting, we say A minus B. What do we get? We have our A, which is 1, 2, 3, 4. Minus B is 5, 6, 7, 8. So when you subtract them, again, the same rule applies. The first element, which is 1, minus 5. And again, you come here 2, minus the other element on this side is 6. You come to 3, minus 7. And lastly, you come to 4, minus 8. So this gives us minus 4. This is minus 4. 1 minus 5 is minus 4. 2 minus 6 is minus 4. 3 minus 7 is minus 4. And 4 minus 8 is minus 4. So A minus B is equal to minus 4, minus 4, minus 4, minus 4. What of B minus A? B minus A, now you start with B. If you are told A minus B, you start with A, then you subtract B. If you are told B minus A, you start with B, which is 5, 7, 6, 8. 1, 3, 2, 4. So in this case again, the first element minus the first element is 5 minus 1, then 6 minus 2, then 7 minus 3, and lastly 8 minus 4. So from here we get 5 minus 1 is 4, 6 minus 2 is 4, 7 minus 3 is 4, 8 minus 4 is 4. This is B minus A. So class, you note that A minus B is minus 4 minus 4 minus 4 minus 4. While B minus A is 4, 4, 4, 4. Therefore, we conclude by saying that A minus B is not equal to B minus A. Remember, we said A plus B is equal to B plus A. So the moment you add matrices, you say that in addition of matrices, they become commutative. 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 When you can take A and then you add B and again interchange them, you say B plus A. It gives you the same result, irrespective of how many times you interchange them. When you interchange them, it gives you the same result as for the addition. So you say they are commutative. But in subtraction, we notice that A minus B is not equal to B minus A. Therefore, they are non-commutative, or they are not commutative. They are non-commutative. Let's take another example. Let's take another example of adding. Let's say we have D. Matrix D is equal to 5, 8, 9, 10. And matrix F equals to 4, 2, 3, 1. What is A? What is D? What is D plus F? D plus F, you first of all start by writing matrix D, which is 5, 10, plus F is 4, 2, 3, 1. So in adding this, the first element you add with the first element. 5 plus 4 is 9. 8 plus 2 is 10. 9 plus 3 is 12. 10 plus 1 is 11. So D plus F is equal to 9, 12, 10, 11. What if we want F plus D? So suppose we want F plus D. What do we get? We start with F. Which is our F? 4, 2, 4, 3, 2, 1. Plus our D is 5, 8, 9, 10. First element added with the first element, you get 9. Plus 8, you get 10. 3 plus 9, you get 12. 1 plus 10, you get 11. So D plus F is 9, 12, 10, 11. And F plus D is 9, 12, 10, 11. Therefore, we conclude by saying that D plus F equals to F plus D. And we say that they are commutative. They are commutative. If you multiply them irrespective of whichever side they are, if you add them, irrespective of whichever side they are, they give you the same result. When they give you the same result, you say they are commutative. When you subtract them, subtraction, D minus F. What is D minus F? We have D as 5, 9, 8, 10. Minus F is 4, 2, 3, 1. So D minus F, the first you subtract the first. 5 minus 4, you get 1. Then 8 minus 2, you get 6. Minus 3, you get 6. 10 minus 1, you get 9. So we have 1, 6, 6, 9. Then F minus D. F minus D. So F is this, 4, 2, 3, 1. Minus D is 5, 5, 9, 8, 10. What do we get? Here we have 4 minus 5 is minus 1. 4 minus 5 is minus 1. Then 2 minus 8 is minus 6. 3 minus 9 is minus 6. 1 minus 10 is minus 9. So we have D minus F is 1, 6, 6, 9. And F minus D, when you change them, when you interchange them, gives you minus 1, minus 6, minus 6, minus 9. Therefore, F minus D Therefore, F minus D is not equal to D minus F. They are non-commutative. From there we go to multiplication. Multiplication of matrices. So in multiplication of matrices, I want you to be keen, class. If we write various types of the order of matrices, suppose we have 2, 3, 4, 5. As A, let's say A equals to 2, 4, 3, 5. Then B equals to 1, 2, 3, 4. Then let's say we have C equals to 2, 1. D equals to 2, 6. And F equals to 3, 2, 1. Let's have that example. Number one, the first thing that you must do, first of all, before I take you to multiplication, I want to take you to a very simple minor step that we've just jumped. Multiplication by scalar. Multiplication but with a scalar. Just keep this at the back of your mind because this is just less than a minute. So when we want to multiply with a scalar or a scalar, we say if we have a scalar of 2 or a scalar of 2, you multiply by this 2, 4, 3, 5. If you want to multiply this, you simply take the scalar, multiply by the first element, which is 4. 2 by 2 is 4. Then the next one is 2 by 3 is 6. Then 2 by 4 is 8. Then 2 by 5 is 10. Suppose our scalar is a half. You multiply by, let's say 6, 8, 10, 4. What do you get? Just open the bracket. 2 times this scalar multiplies all the elements. So 2 times 6 you get 3. 2 times 10 you get 5. 2 times 8 you get 4. 2 times, not 2 but half. Half times 6 you get 3. Half times 8 you get 4. Half times 10 you get 5. Half times 4 you get 2. Suppose we have a scalar of a third of 6, 2, 5, 1. What do we get? A third times 6 is 2. A third times 2 is 2 over 3. Then a third times is 5 over 3. And lastly, a third times 1 is 1 over 3. So this is multiplication from here. This is multiplication by a scalar. So you simply take the scalar, multiply by every element. So now we come to multiplication by other matrix, by another matrix. Multiplication of a matrix and another matrix. So we have our example here. We'll just simply use them again. 2, 4, 3, 5. 2, 4, 3, 5. Okay, that we have 1, 2, 1, 2, 3, 4. And then we have 2, 6, 2, 1, 2, 6. Another one is 3, 2, 1. 3, 2, 1. So if this is our matrix A, B is equal to that. Let's name this C. Let's name this D. Let's name this E. So in multiplication, multiply by another matrix. So let's say we want to multiply A times B. So A times B. Times can also be represented by A dot B, which is A times B. What do we get when we multiply A times B? So number one, identify the order of the matrix. This is a 1, 2. This is a 2 by 1, 2 matrix. And this is also a 1, 2. This is a 2 by 1, 2 matrix. So this is a 2 by 2 matrix and a 2 by 2 matrix. So when the columns of the first matrix equals to the rows of the second matrix, then we say that they are compatible. If they are compatible, there is no conflict, they are together, then you can multiply them. I want to repeat. If the column of the first matrix A equals to the row of the second matrix B, we say that they are compatible. The easiest way to do it, just arrange here A. If you say A times B, bring their order here. You say A times B. You say A is a 2 by 2 matrix. Then B is also a 2 by 2 matrix. If these are the same, you say they are compatible. Compatible. They are not conflicting. You can easily multiply the two matrices. And if you multiply them, the resulting answer becomes what remains here and what remains here. The resulting answer becomes a 2 by 2 matrix. This 2 by 2 matrix. Let's now multiply A by B. A multiplied by B, you get A, which is 2, 3, 4, 5, multiply by 1, 2, 3, 4. I want you to be key in class. In multiplication of in multiplication of matrices, you multiply the rows of the first matrix by the column of the second matrix. So in our situation, we multiply the rows. You multiply matrices going like that. So the rows of the first matrix multiplied by the column of the second matrix. So in our case, we multiply 2 by 1. The first element multiplied by the first element, which is 2 by 1. Then you add to the second one multiplied by the second on this side. Second, so you multiply by 4 times. Then you go to the next one here. You can cover this. Then you say 4 times 2. The next one, not 4, but 2 times 1, sorry. 2 times 1 plus 4. 2 times 1 plus 4 times 2. Then the next one is 2 times 3. 2 times 3 plus 4 times 4. Then the first row must clear the 2 columns to get the 2 values. Then you go to the second row. The second row, you cover this, you get 3 times 1 plus 5 times 2. You finished with this row and this column. Now it is this row and the next column. So it is 3 times 3 plus 5 times 4 plus 5 times 4. So when you open this up, 2 times 1 is 2. 4 times plus 4 times 2 is 6. Then 2 times 3 is 6 plus 4 times 4 is 16. Then 3 times 1 is 3, plus 5 times 2 is 10. 3 times 3 is 9, plus 5 times 4 is 20. Then the first one becomes 2 plus 6, which is 8. 3 plus 10 is 10. 3 plus 10 is 13. Sorry, that's 8. 3 plus 10 is 13. Then 6 plus 16 is 22. 3 plus 10 is 13. Unique is 13. Then 9 plus 20 is 29. So the first one is 6 plus 2 plus 6, which is 8. The next one is 3 plus 10 is 13. The next one is 6 plus 16 is 22. And then lastly is 9 plus 20 is 29. So this is A times B. So what of B times A? If you want to multiply B times A. So B is 1, 2, 3, 4. Our B is 1, 2, 3, 4. And our A is 2, 2, 3, 4, 5. So B times A equals to 1, 2, 3, 4 multiplied by 2, 3, 4, 5. So you must be very keen because you can make some small errors when multiplying this. So you be very keen, you multiply rows by columns. So when we cover this, the first row is 1 times 2 plus 1 times 2 plus 3 times 3. Then we go to the next column, 1 times 4. 1 times 4 plus 3 times 5. Next one is 2 times 2 plus 4 times 3. And lastly is 2 times 4. 2 times 4 plus 4 times 5. So again here 1 times 2 is 2 plus 3 times 3 is 9. 1 times 4 is 4 plus 3 times 5 is 15. 2 times 2 is 4 plus 2 times 3 plus 4 times 3 is 12. 2 times 4 is 8 plus 4 times 5 is 20. So when you add 2 to 9 you get 11. 4 plus 15 is 19. 4 plus 12 is 16. 8 plus 20 is 28. So what am I trying to say? This is B times A. Previously we had our A times B. Our A times B being equal to A times B being equal to 8, 13, 22, 29. 8, 13, 22, 29. And B times A is 11, 16, 19, 28. Therefore, class, A times B is not equal to B times A. So when they are not equal, you say they are non-commutative. A times B is not equal to B times A, which means that if you pre-multiply B by A, and you pre-multiply A by B, then the answers are not equal. And in that case, when they are not equal, you say they are non-commutative or not commutative. Let's take another example of multiplication. What I require from you, class, is just to be keen, because you may be confused on how you multiply the rows by the columns. So you need to be extremely careful and extremely keen during multiplication process. Let's say our C is equal to 2, 1, and our D is equal to 2, 3, 4, 5. And our E equals to 2, 2, 1. Number 1, identify the order of the matrix. This is a 1 by 2. This is 1, 2. You count rows, then columns, 1, 2 by 2 matrix. And this is a 1, 2 by 1 matrix. So class, suppose we want to multiply C times D. C times D. What do you get? I told you, number 1, you arrange their order. C, which is 1 by 2 matrix, then D, which is a 2 by 1 matrix. So in such a situation, when you have the column of the first matrix equals to the row of the second matrix, we say they are compatible. They are compatible. There is no conflict. You can easily multiply them. So, and when you multiply them, this is a 1 by 2, 2 by 2. So when we multiply this, what do we get? A 1 by 1 matrix. Sorry class, just 1 minute. Let's start with this and then we come to this. Let's come to this, then we go to this. So we want to pre-multiply this first. So here E, I told you these matrices, it is a very simple subtopic, but there's a lot of confusion that it can come with in terms of multiplication. So let's say we have our E, which is 2, 1. You multiply by 2, 3, 4, 5. So this is a 1, 2. This is a 2 by 1 matrix. You multiply by a 2 by 2 matrix. So in such a situation, before I come back to this, in such a situation, if you have a 2 by 1 matrix, you multiply by a 2 by 2 matrix. When you look at these two, they are conflicting. They are not rhyming. They are not compatible. Therefore, you cannot multiply these two matrices. Therefore, DE, you cannot multiply DE because they are not compatible. So the next one, when we have a 1, let's say we have a 1 by 2 matrix and a 2 by 2 matrix. 2 by 2 matrix. When we come to this, I wanted to show you this example because in this example, it's easier to show that they are not compatible first. Then we compare it to our example that we gave here. So our first example, we have a 1 by 2 matrix and a 2 by 2 matrix. So when you multiply these two, the columns in the first matrix equals to the row in the second matrix. Therefore, we say they are compatible. And when they are compatible, you can multiply them. And when you multiply them, the resultant answer becomes what remains, 1 by 2 matrix. The resultant answer becomes 1 by 2 matrix. Therefore, we can multiply this, which is 2 multiplied by 2, 3, 4, 5. So in multiplication, we have CD. So this is C times D equals to that. So when you multiply, remember class, the rows by columns, rows by columns. So 2 by 2 plus 2 by plus 2 by 2 plus 1 by 3. The next one is 2 by 4 plus 1 by 5. So here what do we get? 2 by 2 is 4 plus 1 by 3 is 3. From this side we get 2 by 4 is 8 plus 1 by 5 is 5. So what do we get here? 4 plus 3 is 7. Then 8 plus 5 is 13. So when we multiply C times D, which is 1 by 2 and a 2 by 2 matrix, you get a 1 by 2 matrix. Let's see if this is a 1 by 2 matrix. From here, we get 1 row by 2 columns. 1 by 2. So the reason why I didn't want to explain this first is because I wanted to show you if they are incompatible. Then when they are incompatible, you don't even proceed because you cannot multiply them. So in such a situation, you cannot multiply DE. And our D is this and our E is 2, 1. So let's have another example, class. Let's say our matrix A equals to 6, 2, 3, 4. Our matrix B equals to 1, 1, 8, 4, 6. A times B. How do we get A times B, which is written as AB? Rows, class, and columns. So you multiply 6 by 1 plus 2 by 8, then 6 by 4 plus 2 by 6. The next one is 3 by 1 plus 4 by 8. Then the last one is 3 by 4 plus 4 by 6. So here what do we get? 6. 6 by 1 is 6 plus 2 by 8 is 16. 3 by 1 is 3 plus 4 by 8 is 32. 6 by 4 is 24 plus 2 by 6 is 12. 3 by 4 is 12 plus 4 by 6 is 24. So when you add 6 plus 16, you get 22. When you add 3 to 32, you get 35. 24 plus 12 is 36. Then again 12 plus 24 is 36. So you confirm. The moment you get your answer, take your time, go back here and confirm if you multiplied well, because the signs may be confusing and human beings are to mistakes. So you can make a minor mistake that will cost you the whole answer. So you come back again, you multiply 6 by 1 plus 2 by 8, 6 by 1 plus 2 by 8, 6 by 4, which is 6 by 4 plus 2 by 6, correct. 3 by 1 plus 4 by 8, correct. 3 by 4 plus 4 by 6, correct. Then 6 by 1 is 6, 2 by 8 is 16, 3 by 1 is 3, 4 by 8 is 32, 6 by 4 is 4, 2 by 6 is 12, 3 by 4 is 12, 4 by 6 is 24. Then you add 6 plus 16 is 22, 3 plus 32 is 35, 24 plus 12 is 36, again 12 plus 24 is 36. So this is the correct answer for AB. Again, let's BA is 1, 8, 4, 6, multiply by 6, 3, 2, 4. So again, class, be careful when you are multiplying this. It is 1 by 6, 1 by 6 plus 3 times plus 4 times 3. That's the first one. The second one is 1 by 2 plus 4 times 4. The next one is 8 by 6 plus 8 by plus 6 by 3. Next is by 2 plus 6 by 4. What do we get here? 1 by 6 is 6 plus 4 by 3 is 12. 1 by 2 is 2. 4 by 4 is 16. 8 by 6 is 48. Plus 6 by 3 is 18. 8 times 2 is 16. Plus 6 by 4 is 24. So when you add them, 6 plus 12, 6 plus 12 is 18. 6 plus 12 is 18. Then 2 plus 16 is 18. 48 plus 18 is 66. That's 66. Then 16 plus 24 is 40. Class AB is equal to 22, 35, 36, 36. While BA is equal to 18, 66, 18, 40. Therefore, we conclude by saying that AB is not equal to BA. So, when we conclude that way, we say that they are not commutative. So, we are done with multiplication. We want to see different types. We are almost finishing. Different types of matrix. So number one, we have a zero matrix. Zero matrix can be that. This is a 1 by 1. Okay, let me just finish. Can be that. And also that, and can be that. So this is a 1 row by 1 column matrix. This is a 1 row by 2 columns matrix. This is a 2 rows, 2 rows by 2 columns matrix. Now, this is a 1 row by 3 columns, and this is a 3 rows by 1 column. Therefore, class, this matrix is called a zero matrix. A matrix where all the elements are 0 is called a zero matrix. The second one, we have identity matrix. Identity matrix is represented by 1 0 0 1, or let me just get a space for this. 1 1 1. Zero, zero, one. So this is also identity matrix. You can see this one, the same diagonal. This one also same diagonal. So this is an identity matrix. There's a reason why I've given you this, because I will refer to it in our next example. The third one, we have singular matrix. In a singular matrix, the determinant of that matrix equals to 0. In a singular matrix, the determinant equals to 0. We'll also do an example on that. And lastly, number 4, we have the inverse matrix. So now we want to do something to do with inverse matrix, inverse of a matrix, or the inverse matrix. Then we make comparison with the examples that I've given you. Let's say we have matrix A equals to 4, 2, 7. And you are told to get the inverse of this matrix. Number one, you get what we call the determinant of a matrix. How do we get the determinant of a matrix? In getting a determinant of a matrix, I want you to be careful here. Let's call this diagonal the leading diagonal, and let's call this diagonal the other diagonal. So in getting the determinant of a matrix, what do? You multiply the element on the leading diagonal, that is 4 by 1, then you subtract the elements, the elements on the other diagonal multiplied, minus 2 times 7. What do we get? 4 by 1 is 4, minus 7, 2 by 7 is 14, 4 minus 14 is minus 10. That is a determinant of a matrix. Again, class, in determining the determinant of a matrix, you multiply the elements along the leading diagonal, that is 4 times 1. You subtract the other diagonal elements multiplied, that is 2 times 7. So that is 4 minus 14, you get minus 10. Now, we want to get the inverse of this matrix. Be very careful here, class. So to get the inverse of this matrix, whatever is along the leading diagonal, you interchange them, or you swap them. So when 4 is here, 4 comes down, and when 1 is here, 1 comes up. Then whatever is in the other diagonal, you maintain them, but you change the sign. If it is 7, it is positive 7. Therefore, you just change the sign to become negative 7. This other one also becomes negative 2. Then whatever you get, you divide by, whatever you get, you divide by the determinant, which is minus 10. Therefore, the inverse of A is written as A inverse. What do you get? Minus 1 over 10. Minus divided by minus is plus, so therefore this becomes 7 over 10. Minus and minus becomes positive, therefore this becomes 2 over 10. Then positive 4 divided by minus 4, you get minus 4 over 10. So this is the inverse, which can also be written as, you can decide to factor 1 over 10 outside, and you remain with minus 1, 7, 2, minus 4. Therefore, the inverse of a matrix is 1 over the determinant of this matrix. You get the inverse of A. Another example. Example 2. Suppose we have 2, 3, 4, 5. If this is our B, what is the inverse of B? Number 1, get the determinant. And when you get the determinant, I told you the leading diagonal, you get the product of the leading diagonal. This is the leading diagonal, which is 2 times 5, minus the other diagonal, which is 4 times 3. So what do we get? 10 minus 12. You get minus 2. After that, whatever is along the leading diagonal, swap them or interchange them. So 5 comes up here, 2 goes down. Then whatever is here, change the signs. So this becomes minus 3, this becomes minus 4. Then whatever you get, just divide by the determinant, which is minus 2. So this we get minus 5 over 2. This we get 3 over 2. This we get 2. Minus 4 divided by minus 2 is 2. 2 divided by minus 2 is minus 1. So this is the inverse of B. So we want to multiply the matrix B by its inverse, or the matrix A by its inverse. What do we get? So let's start with A. 4271. A is 4271, and then the inverse of A is minus 110, minus 110, 710, 210, 7 over 10, then minus 4 over 10. So we want to multiply A multiplied by the inverse of A. What do we get? So let's multiply A by inverse of A. So you get 4271 times minus 110, 210, then 7 over 10 minus 4 over 10. So be careful here. In multiplication, this does not spare a teacher, and this will not spare also a student. You must be very keen when you are multiplying rows and columns. So when you come here, we get 4 times minus 10 minus 1 over 10 plus 7 times 2 over 10. Again 4 times 7 over 10 plus 7 times minus 4 over 10. Next one is 2 times minus 1 over 10. You be very careful. Then plus 1 times 2 over 10. The last one, 2 times 7 over 10 plus 1 times 4 over 10. 1 times minus 4 over 10. From here, I told you be very, very, very careful, very keen when you are multiplying. So let's see. So as you multiply, you can make very small mistakes that will cost you the whole question. So you be very careful. So from here, 2 times 7 over 10 plus, okay, right. So from here, we have 4 times minus 1 over 10 is minus 4 over 10 plus 7 times 2 over 10 is 14 over 10. Careful class. Be very careful, so you have to concentrate. Don't even blink. Don't smile at this moment, because we are dealing with numbers that are petty. These numbers are just stubborn, but they are very easy to deal with. So you want to minimize them once and for all. 4 by 7 is 28 over 10. 4 by 7 over 10 is 28 over 10. Then plus 7 by minus 4 over 10 is minus 28 over 10. Class, be very careful with the signs. Signs, signs, signs. Next one is 2 times minus 1 over 10 is minus 2 over 10 plus 1 times 2 over 10 is 2 over 10. 2 times 7 over 10 is 14 over 10 plus 1 times minus 4 over 10 is minus 4 over 10. So class, be careful. Here we want to solve minus 4 over 10 plus 14 over 10. is the same as 14 over 10. This is the same as 14 over 10 minus 4 over 10. When you solve this, you get 10 over 10, which is 1. So when you solve this, you get 1. Come to the next one. 28 over 10 plus minus 28 over 10. I told you the last time that plus times minus is minus, plus times plus is plus, minus times minus is plus. Therefore, 28 over 10 plus minus 28 over 10 is the same as 28 over 10 minus 28 over 10. That is 0. For the third one is 0. Then we come to the second one. When you are naming the matrices, you go 1, 2, 3, 4. You go vertically like that. So the third one, we have 2 times minus 1 over 10 is minus 2 over 10 plus 2 over 10. This is the same as 2 over 10 minus 2 over 10 is 0. Then here, over 10 plus minus 4 over 10 is the same as 14 over 10 minus 4 over 10, which is 10 over 10, which is equal to 1. So the last one is 1. Therefore, class, when you multiply A by the inverse of A, you get 1, 0, 0, 1. This is an identity matrix. We want to see if you pre-multiply the inverse first. In this case, we multiplied A by A inverse. What if we want to multiply A inverse, look here class, by A? Let's see if we are also getting the same answer. So our A inverse is minus 1 over 10. Our A inverse is minus 1 over 10, 2 over 10, 7 over 10, and lastly minus 4 over 10. And our is 4271. So we want to multiply A inverse by A. What can we get? So let's multiply this by this. That is minus 1 over 10, 7 over 10, 2 over 10, minus 4 over 10. You multiply by 4271. Class, be careful about the signs and how you multiply the rows and the columns. So you can temporarily cover that. Then we multiply minus 1 over 10 times 4, this times this, plus 7 over 10 times 2. So this has finished with this. Therefore, this multiplies the other one, which is minus 1 over 10 again, times 7, plus 7 over 10 times 1. Next is 2 over 10 times 4, plus minus 4 over 10 times 2. Good. Next is 2 over 10, this by this, times 7, plus minus 4 over 10 times 1. Let's see what this gives us, class. Minus 1 over 10 times 4 is minus 4 over 10, plus this plus 7 over 10 times 2 is 14 over 10. Then here 2 over 10 times 4 is 8 over 10, plus minus 4 over 10 times 2 is minus 8 over 10. This one, minus 1 over 10 times 7 is minus 7 over 10, plus 7 over 10 times 1 is 7 over 10. Then lastly, 2 over 10 times 7 is 14 over 10. Plus minus 4 over 10 times 1 is minus 4 over 10. So minus 4 over 10 plus 14 over 10 is the same as 14 over 10 minus 4 over 10. Careful class. This is the same as 14 over 10 minus 4 over 10, which is equal to 10 over 10, which is equal to 1. So the whole of this gives us 1. Let's write it somewhere here. That is for this. Let's solve this. Minus 7 over 10 plus 7 over 10 is the same as 7 over 10 minus 7 over 10. 7 over 10 minus 7 over 10 is 0. The other one, 8 over 10 plus minus 8 over 10 is the same as 8 over 10 minus 8 over 10, which is 0. Then 14 over 10 plus minus 4 over 10 is the same as 14 over 10 minus 4 over 10, which is 10 over 10, which is equal to 1. Therefore, class, there is a simple conclusion that we want to draw from the multiplication of a matrix and its inverse. So when you multiply a matrix A by its inverse, you will get an inverse of a matrix A multiplied by A, which is equal to identity matrix, which is equal to 1, 0. Class, again, when you multiply a matrix by its identity and you take that identity, you multiply by the matrix again, you will get, and when you take that inverse and multiply by the matrix again, you get an inverse. You get an identity matrix, which is 1, 0, 0, 1. When you multiply, class, again, be careful, a matrix A by its inverse, you get the inverse of A multiplied by A, which is equal to identity matrix, which is equal to 1, 0, 0, 1. So, in short, when you multiply an inverse of A, when you pre-multiply, another thing you can note, when you pre-multiply, I'm saying the same thing, I'm just saying it differently. When you pre-multiply the inverse of A by A, you get A multiplied by pre-multiplied, pre-multiplied by A inverse. And you get identity matrix, which is 1, 0, 0, 1. Therefore, what conclusion can we make? When such a thing happens, we say they are commutative. They are commutative. So, a matrix multiplied by an inverse, then you take an inverse multiplied by the same matrix, they are equal. You get an identity matrix, which is 1, 0, 0, 1. Class, that is the end of our lesson. Now I want to handle the application, and I will handle like only 4 questions. Then I will give you an assignment. I hope we are still within the time. So as we conclude, we do the application. This application will take very few minutes. So matrices can be applied. When we have a question that you are given, I will I'll make reference to the questions as we solve them. So the first question you are given, I will just read it loud. That is A equals to 2, 3, 4, 6. We just want to solve few questions, and I tell you how they are solved, how we get the solution. B is equal to 11, 4, 3, 1. Then the question tells you to find C such that, find C such that B times C equals to A. Class, this is a very easy question. You just have to breathe in and breathe out, and then you smile. So you are given A, you are given B, but you are not given C, but you are told that B times C equals to A. So how do we get A? How do we get C? Sorry. So just come down here. Start with what you are given here, which is B. Write it down. 11, 4, 3, 1. Then multiply by C. When you are given C, and I told you in multiplication, you represent C by A, B, C, D. This is our C. Then you equate it to A. Our A is 2, 3, 4, 6. So once you are given this, just multiply it normally. So when you open it, you say 11 times A now. Once you are given this, you can solve it in two ways. Number one, you can solve it simultaneously. Number two, you can solve it using the matrix method. But because we are dealing with matrices, we will use matrices to solve it. Therefore, when you are given such an equation, just get the inverse. Get the inverse of A. Now let's get the inverse of A. We said before you get the inverse, you get the determinant. And when you are getting the determinant, you say you multiply the leading diagonals. The leading diagonals is 11 times 1 minus 4 times 3. So this is 11 minus 12. This is minus 1. So determinant is minus 1. Therefore, what is the inverse of this matrix? So the inverse of this matrix, you change the leading diagonals, you swap, you interchange. 1 comes up, 11 goes down. 1 comes up, 11 goes down. Then the other diagonal, you only change the signs. Minus 3, minus 4. And then you divide by the determinant, which is minus 1. So this is the inverse of A. What do we get? This comes to minus 1. Minus 3 divided by minus 1 is 3. Minus 4 divided by minus 1 is 4. Then minus 11 divided by minus 1 is minus 11. This is the inverse of A. Therefore, we want to get the value of A, B, C, D. To get the value of A, B, C, D, or the value of matrix C, you pre-multiply this equation by the inverse. Pre-multiply, class. Pre-multiply. Pre means before. Put it before. So put the inverse before on both sides. You put it before, you multiply by the whole of this. Then you put it before, you multiply by the whole of this. So when we pre-multiply, what do we get? Let me open another page. So here we have minus 1, 4. Then 3 minus 11. You pre-multiply it by 11, 4, 3, 1. 11 you by 2, sorry, by 2, 3, 4, 6. 2, 3, 4, 6 of A. 2, 3, 4, 6. Good. And then we have A, B, C, D. And again, you pre-multiply this, which is minus 1, the inverse, 4. 3 minus 11. You pre-multiply it with this. Good. Class, concentration, concentration. We got the inverse. We got B times C. Class, concentrate here, please. B times C equals to A. Therefore, what we pre-multiply with is the value of B, not the value of A. The value of B, this. We have the inverse. We've already gotten the inverse of B, so we pre-multiply it by B. Don't move, just where it is. So it is B by C equals to A. So our value of B is here. B is 11, 4, 3, 1, multiplied by C. C we can replace by A, B, C, D, equals to A. A is 2, 3, 4, 6. So remember we said get the inverse of this, and we've gotten it. Then pre-multiply by the inverse of B. So what did we get as the inverse? The inverse is here, minus 1, 4, 3 minus 11. Good. You pre-multiply by 11, 3, 4, 1. Then A, B, C, D. Then you equate to, again you pre-multiply this, the inverse by this. That is minus 1, 4, 3 minus 11 multiplied by this value. The value is 2, 3, 4, 6. So let's open up this class. Let's open up this. So here we have minus 1 times 11 plus 3 times 4, 4 times 3 or 3 times 4, then minus 1 times 3 plus 3 times 1. Then here 4 times 11 plus minus 11 times 4. Then here we have 4 times 3 plus 4 times 1. Class, minus 1 times 11, yes, plus 4 times 3. Then minus 1 times 3 plus 3 minus 1 times 3 plus 3 times 1, yes. Then here 4 times 11, 4 times 11 plus minus 11 times 4, yes. Then lastly 4 times 3 plus minus 11. Be careful with the signs, class. That is where I want you to focus on. So what do we get here? Minus 11, minus 1 times 11 is minus 11, plus 4 times 3 is 12, minus 1 times 3 is minus 3, plus 3 times 1 is 3, 4 times 11 is 44, plus minus 11 times 4 is minus 44. Then 4 times 3 is 12, minus, plus, minus 11 times 1 is minus 11. So here what do we get? 12 minus 11 is 1. Then minus 3 plus 3 is 0. Then 44 minus 44 is 0. Then 12 minus 11 is 1. So when you multiply B by its inverse, you get an identity matrix. Then you just simply replace A, B, C, D to represent the value of C. Then on this other side, you also multiply them. So when we multiply this, that is minus 1, 4, minus 1, 4, 3 minus 11, multiplied by 2, 3, 4, 6. What do we get? And meanwhile, we have 1, 0, 0, 1, and then A, B, C, D. So what do we get here? Multiply this rows by columns. So this becomes minus 1 times 2 plus 3 times 3. Then minus 1 times 4 plus 3 times 6. Then here 4 times 2 plus minus 11 times 3. Then the last one 4 times 4 plus minus 11 times 6. So here what do we get, class? This is minus 2 plus 9. This is minus 4 plus 3 times 8. 4 times 2 is 8 plus minus 3 times 11 is minus 33. Minus 11 times 3 is minus 33. Then 4 by 4 is 16 plus minus 11 times 6 is minus 66. So what do we get? Minus 2 plus 9 is 7. Minus 4 plus 18 is the same as 18 minus 4, which is 14. Then 8 plus minus 33 is minus 25. Then 16 plus minus 66 is minus 50. So this is what we've gotten on the right hand side. The left hand side, remember, we had 0, 1, 0, 0, 1. Then A, B, C, D. And then you equate it to 7, 14, minus 25, minus 50. So class, when you open up this further, you get 1 times A, which is A, plus 0 times C, which is 0. So therefore you get A. Then 1 times B is B, plus 0 times D is 0. Therefore B plus 0 is B. Then 0 times A is 0, plus 1 times C is C. Therefore 0 plus C is C. Then 0 times B is 0. Any number multiplied by 0 is 0. Any letter multiplied by 0 is 0. 0 by B is 0, plus 1 by D is D, equals to 7, 14, minus 25, minus 50. Therefore, we said A, B, C, D represented our C. So C is equal to 7, 14, minus 25, minus 50. And you have all the answers. So the next example, I think you followed it. As we finish, today there were so many signs that were to be taken care of. So another example, on application, find the inverse. Another example, find the inverse of 2, 3, 5, 4. Otherwise, solve the equation 2x plus 5y equals to 9 and 3x plus 4y equals to 6. Find the inverse of this. Before you find the inverse, get the determinant. Let's move slightly forward, faster kidogo. But class, just concentrate in the next few minutes. Such an exam, I repeat, must come in your KCSE examination this year. Such an example will come. The letters might be different, but the setting style will be the same. So it will come. So in the first one, find the inverse. In finding the inverse, you identify the leading diagonal. You get the determinant, and in getting determinant, that is 2 times 4 minus 3 times 5. This is 8 minus 15, which is minus 7. Then inverse, you just simply interchange the leading diagonals. Interchange the element in the leading diagonals. This becomes 4, 2. 4 goes here, 2 comes down. Then the other diagonal, simply change the signs. Becomes minus 5. Then here minus 3. Then divide by the determinant, which is minus 7. So the inverse is minus 4 over 7. Minus 5 divided by minus 7 is 5 over 7. Then minus 3 divided by minus 7 is 3 over 7. Then 2 divided by minus 7 is minus 2 over 7. So this is the inverse of matrix 2, 3, 5, 4. Then you are told to solve this. So in solving this, it's very easy, class. Simply identify where x's are, collect them together, and y's, collect them together. So here, 2x plus 5y, just write 2, 5. Then 3x plus 4y, just write 3, 4. Then write the value of x, y. Then equate it to 9, 6. So class, 2x plus 5y can be written as 2, 5. 3x plus 4y can be written as 3, 4. Then xy, and then 9, 6. X's and y's. X's on one side, 2, 3, 5, 4. Then xy equals to 9, 6. Then, as I told you, it is just the same as the example that we did. They said b times c is equal to a. So find the value of c, which is x and y. So what you do again here is very easy. Get the inverse of this matrix, then pre-multiply that inverse by this side, and again pre-multiply it on the other side. So you pre-multiply it on both sides. So on this side, if you pre-multiply by the inverse, so there is no need of getting an inverse, because this and this, we were told first of all to find the inverse of this. This and this are the same, and their inverse is this, which is minus 4, 7, minus 4 over 7, 3 over 7, 5 over 7, minus 2 over 7. You multiply by this, 2, 5, 3, 4. Then xy equals to, I said you pre-multiply both sides. You put it before. If you put it after, it can give you a different value. Put it before. So when you put it before, this becomes minus 4 over 7, 3 over 7, then 5 over 7, and minus 2 over 7, multiply by 9, 6. So this equals to, comes here. I told you, class, that when you multiply a matrix by its inverse, gives you an identity matrix. So there is no need of opening this. This will give you an identity matrix. When you multiply this, you will get 1, 0, 0, 1. Multiply by xy equals to, what do we get when we multiply on this side? So from the first example I told you, this is a 2 by 2 matrix multiplied by a 2 by 1 matrix. This is a 2 by 1 matrix. Therefore, they are compatible. You can multiply them. And the resulting answer becomes a 2 by 1 matrix. So let's multiply this, class. Minus 4 over 7 times 9. Minus 4 over 7 times 9. Plus 5 over 7 times 6. Then here 3 over 7 times 9 plus minus 2 over 7 times 6. What do we get? Minus 4 over 7 times 9 is minus 36 over 7 plus 5 over 7 times 6 is plus 30 over 7. This gives us minus 30 over 7, minus 36 over 7 plus 30 over 7 is minus 6 over 7. Then you solve the other one here. Just come here so that we don't open the other page. 3 over 7 times 9 is 27 over 7 plus minus 2 over 7 times 6 is minus 12 over 7. This one you get 27 over 7 minus times plus is minus 12 over 7, you get 15 over 7. Therefore, the values of x and y, we have minus just here. Let me make sure you be neat. Just check here. The first value is minus 6 over 7, and the next value is 15 over 7, which we equate to 1001, then x, y. When you multiply this, you get 1 times x is x, plus 1 times x is x, plus 0 times y is 0. So x plus 0 is x. Then 0 times x, 0 times x is 0, plus 1 times y is y. So the value of xy equals to minus 6, 7, 15, 7. So this is our answer that we require. X equals to, just pick the first value, minus 6 over 7, and y equals to, you pick the next one is 15 over 7. So class, the last example because of time. So we have 2x, x squared, 2 and 1. So you are told to determine the values for which the matrix below has no inverse. Any matrix without an inverse, the determinant of that matrix is equated to 0. Therefore, just get the determinant of this matrix, which is 2x times 1 minus 2 times x. So this is 2x minus 2x squared equals to 0. Therefore, from here, just factor, a common factor here is 2x into 2x goes into 2x, 1 minus, factor out 2x minus 2x goes here, x, which is equal to 0. Therefore, 2x equals to 0. From here, x equals to 0. 2x equals to 0, x equals to 0. Then from here, 1 minus x, also you equate these two by 0. X equals to 1. So therefore, the values of x is 0, and another value of x is 1. So today we are through with our lesson. Therefore, you will, from the page, I will give you an assignment. You do from number 4 to number 10. Do from number 4 to number 10 as your assignment. And thank you very much, class. Again, as a punchline, take care of the signs because they're a bit confusing, but it is an easy topic. Matrices will never miss in any exam, and I'm sure this KCSE examination, it will come. So be ready for it. Just practice makes perfect. Thank you very much. God bless you all. I hope you enjoyed. Thank you.